So here we are. We're going to do Lewis structures for simple molecules. All right. And before we actually do our first Lewis structure, I just wanted to go over some basics with you. All right. So the Lewis structure is going to show you um, potentially what your molecule will look like. All right. So we're not doing VSEPR models, but this is going to just show you kind of like a structural formula for that molecule. All right. And because valence electrons are the ones that are involved in the bonding process, we're going to do Lewis structures with those valence electrons. And there are two ways that valence electrons are drawn out on Lewis structures. So the first way, we have a dash, okay, and this represents a bond, okay, and so the dash is going to be between two different elements. So, for example, like CH. Okay, so we'll put a dash saying that these are connected to each other, and so that's representing a bond. Um, there are So how many electrons are in that dash? There are two electrons represented in the dash. And I'll just put dash. All right. Now, after we've gone through and we've bonded everything together, we still may have some valence electrons left over, and we represent them by two dots. Okay, and it's always going to be two dots. It's always going to be two dots, and these dots are known as lone pairs. So this is one lone pair, and if you have multiple, it would be, however many lone pairs you have. And so, of course, that's two electrons there. And so think about, excuse me, electron dot diagrams. And so if you had a lone pair, it would be written out like that. All right. And so let's look at our first example here. So if we look at group A, our simple molecules, our first compound is CH4. Excuse me, CH4. So the first thing I'm going to do is I'm going to count the valence electrons. How many valence electrons does carbon have, and how many valence electron hydrogen has? All right, so the easiest thing that you can do to count your valence electrons is you want to find carbon on your periodic table, and you want to find your hydrogen on your periodic table. And I see that carbon is in group 1. Hydrogen is in group 1. Carbon is in group 4. And if we recall from our electron dot diagrams, okay, if the element's in group 1, it has one valence electron, and if it's in group 4, it has four valence electrons. All right, so we're going to count these up. Okay, so our valence electrons, we're looking at, there's one carbon, all right, and it has 4, plus hydrogen has 1, but this little 4 that's at the bottom here is called a subscript, and it's telling me how many hydrogens are in this formula. So there's 4 of those. So each of the hydrogens have 4 valence electrons. So the total number is 4 plus 1 times 4, which is 8. Okay, so I have 8 valence electrons to work with in this compound CH4. All right, so what I'm going to do is when I'm looking at this and I'm going back to my rules, hydrogen can never be in the middle. All right, so if hydrogen cannot be in the middle, carbon will be. All right, and it's really just that simple for what we're doing in this class. All right, so what I'm going to do is move my paper up a little bit. I'm going to put carbon in the middle. All right, and now I'm going to connect it to the four hydrogens, and I do that with the little dashes I was talking about earlier. So that's one hydrogen, that's two hydrogens, that's three hydrogens, and then that's four. I almost didn't leave enough space there. Okay, now before I do anything else, I always like to come back and count to see what I have. All right, and so we're going to count, and I'm going to circle the carbon. Going to circle the carbon, and I see that each dash, remember, is two electrons, so it's 2, 4, 6, 8. Oh, wow. First of all, I've used all 8 valence electrons that I have to work with. And then remember, carbon can have an octet. So carbon has 8 electrons around it. Hydrogen will do more of what we call a duet. So it will have a maximum of 2. So when I look at this hydrogen, it has 2. That dash represents 2. 2 electrons here, 2 electrons here, and then 2 electrons here. All right, so with all of this beautiful extra pink and yellow here, what I see is that my Lewis structure is complete. Now, of course, for you guys to make it simpler, I'm going to rewrite it over here without all the circling. And put it so you can actually see what I just did. And so that is the Lewis structure for CH4. All right, let's do another one. Okay, NH3, that's the next one on your paper. All right, I think I'm going to do it this way so I have more space. All right, so NH3. Okay, first thing I'm going to do is find my valence electrons. How many valence electrons I'm working with. Remember, E negative is electrons. All right, so when I look at my periodic table, I notice that when I look at my periodic table and I'm looking at the location here, let me go ahead and get that off. Oh, I could have left that one. All right, so H is in group 1, N is in group 5. All right, and so I'm like, okay, group 1, 1 valence electron, group 5 has 5. All right, so let me count up what I got. So NH3, there's 1 N, and if you're like, how do you know there's 1 N, like it was only 1 carbon? If there isn't a small number after the element symbol, it's understood to be 1. So that's going to be 5 plus hydrogen, 1 valence electron. Got ahead of myself. 1 valence electron, and there's 3 of them. So that's going to be multiplied by 3. So 5 plus 3 equals 8. So once again, I'm dealing with 8 valence electrons. Hydrogen cannot be in the middle, but nitrogen can. So I'm going to do that. I'm going to put my little N here. Okay. And now I'm going to connect those 3 hydrogens to the nitrogen. All right. And so when I do that, I have 2, 4, 6. I've used up 6 of the 8 valence electrons that I have. I can't do another dash. I can't do another bond because I don't have another hydrogen. Okay. So if you have leftover electrons, okay, and your terminal electrons will not take anymore, because hydrogen, you can't put any lone pairs on hydrogen, then that means those extra electrons will go as lone pairs on the central atom. Okay. Now, I always like to check my work, make sure I'm doing it correctly. So when I circle my nitrogen, okay, I count 2, 4, 6, 8. Nitrogen has an octet. And now let me see if I have a duet around my hydrogens. That one has 2, that one has 2, and that one has 2. And we can do this because if you remember, these electrons are being shared. All right, going to do one more example with you guys on video, I should say. All right, so next we have, let's do SiF4. SiF4. And so we're going to count up our valence electrons. All right, so Si, you look at your periodic table. Si is located in group 4 here. Okay, and F is in group 7. All right, so there's one Si, so that's going to be 4, plus F has 7 valence electrons, and I have 4 of these, so that's going to be 28. So 4 plus 28 is 32. I got 32 valence electrons that I'm dealing with. Now F is a halogen, and if you go back to the rules, halogens, cannot be in the middle. They cannot be central atoms. So Si is going to go in the middle, and I'm going to connect the 4 F's to the Si. So here we go. 1, 2, 3, 4. All right. And so now I'm like, wow, I've got all of this connected, and I've used 8. I've used 8 electrons. And so I got like, what, 24 to go? And I'm like, so where will these go? These will go as lone pairs around your F's. So let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. And that's how many electrons you had to work with. All right, so always, 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 always go back and check, make sure. So when I'm looking at the Si, I got 2, 4, 6, 8, got an octet there. So let me check my F's. This F right here has 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. And so I have an octet around all of those. All right, so let's do these couple of other problems and see what we come up with.